This is a video to help with distance, speed, time problems. So Aga, apparently she's a girl, she travels by car for how long? For 1 hour and 6 minutes to reach a railway station, which is 55 kilometers away. And then she goes by train and she travels 110 kilometers by train at 80 kilometers per hour. Okay, fine. It then says, A, what's the average speed of her journey? Well, speed is equal to distance over time. If you're not comfortable with this distance speed triangle and how to work it, that's a very important thing. You need to, tell me you don't understand it and seek to get some help. Absolutely essential. So make sure you do that if you don't understand this properly. But speed is equal to distance over time. Distance divided by time. I'll just put in the information you have then. The distance for the car is equal to 55 kilometers, and her time is equal to 1 hour and 6 minutes. Now, as you know, speed sounds something like 55 kilometers per hour or 30 meters per second. It's never like 55 kilometers per hour and minutes. So we just need to get one single unit here. We need to get hours or minutes. Now, when you're traveling by car, you're going to find that the speed will be kilometers per hour usually. So I'm going to convert these 6 minutes into hours. So this is equal to 55 kilometers divided by 1 plus 6 over 60. Okay, that's how you convert minutes into hours. 6 over 60 is going to give you that. So if I then go to a calculator, we can do this. Okay, so here's the calculator. 55 divided by 1 hour plus 6 over 60, which is equal to 50. So your calculator will work in a similar way. So 50 kilometers per hour, that's the speed, is equal to 50 kilometers per hour. That's part 1. Part 2, how long will the train journey take? Well, the train journey, time is equal to distance divided by speed. So time is equal to the distance for the train is 110. The speed is 80 kilometers per hour. We put it into our calculator. We're going to get 1.375. Now, on your calculator, you click this button here, the degrees, minutes, and second button, and it'll automatically convert it into 1 hour, 22 minutes, and 30 seconds, which is normally the way we give time. We don't normally give time as in 1.3 hours or 1.375. Now, part C, what's the total distance travelled? So you add up the 55 kilometres and 110 kilometres, that's 165 kilometres. That's the total distance travelled. Part D, what's the overall time take? Now you have a choice, I suppose. You can add up the time like this time here, and 1 hour 6 minutes. There's the two times. Okay, that's going to give you 2 hours 28 minutes and 30 seconds, which is not great. Because in the next part of the question they're going to be asking you for the average speed. So the other way to do the overall time is to use this time here. So 1.375 hours plus this here, the 1 hour and 6 minutes, which is equal to 1 hour 0.1, which is equal to 2.475 hours. E, what's the average speed? Go back to your triangle. Speed is equal to distance over time of the whole journey. Well, the whole journey is equal to 165 kilometers, and the whole time is 2.475 hours. So you see, now we have the units nicely. We have kilometers per hour. So 165 divided by 2.475. So 165 divided by 2.475 is equal to 66.6666. That's 2/3, okay, as a fraction. Oh, look, 200 over 3, 66.66. That's equal to 66.66 recurring kilometers per hour, okay, and that's equal to 66 2/3 kilometers per hour. Now, part F. Says the next day, Aga and her friend Peter travelled to Rosslare Harbour in separate cars. The ratio of the average speeds of Aga's car to Peter's car is 8:9, and if it takes Peter 5 hours to travel a distance of this 270 in his car, what's the average speed of Aga's car? Now you'll see the first thing I did was I wrote in Aga and Peter, and the ratio is 8:9. The question says, what's the average speed of Aga's car? So we're in speed now. So let's work out what Peter's speed is. So Peter's speed is equal to the distance of 270 divided by his time, and he took 5 hours. So that's his speed. So 270 divided by 5. So we'll do 270 divided by 5 is equal to 54 kilometers per hour. That's his speed. 54 kilometers per hour. So we'll write in here 54 kilometers per hour. Before I complete Aga's time, her average speed, let's look at maybe say a simpler example. Imagine that Peter was doing, say, 20 kilometers per hour. Okay, per hour here. And the ratio is, say, 2 to 1. What would her speed be now? Because he's traveling twice as fast as her. For every 1 kilometer per hour he's doing 2. He's traveling twice as fast. So what's half the speed of this? That's going to be 10 kilometers per hour because it's twice. What happens if we have another situation here? What happens if the ratio is, say, 1 is to 4? In other words, he's traveling 4 times as fast. Or maybe then just say he's doing, say, 100 kilometers per hour. How fast is Aga going now? Well, she's going 4 times slower than him, so we'll make that, it'll be 25 kilometers per hour. Lastly, let's say he's doing, just say the ratio is 2 to 3, and he's doing 60 kilometers per hour. What speed is Aga doing now? What we do is divide the 60 by 3, it's going to give me 20, and multiply it by the 2. It's going to give me 40 kilometers per hour. Okay, so similarly, up here, what we do is we divide Peter's 54 kilometers by 9 to get one part, and 54 divided by 9 is equal to 6. And then we multiply the 6 by the 8. 6 8 is 48. 48 kilometers per hour. So the average speed of Aga's car is 48. Okay, obviously all this thing over here was just help for you. It's not part of the question particularly. It's to help you understand how ratios work with regard to this speed. Okay, I hope that helps. Thank you.